Hello. In this quick tutorial, I want to cover sushi belts and the way they are set up. What is a sushi belt? A sushi belt is a belt looped on itself, rotating items for consumption. It's inspired by the popular Japanese restaurant style, where sushi is served on a conveyor belt rotating around the restaurant, allowing customers to pick up and choose a dish as it passes by. In DSP, the customers are replaced by factory buildings like assemblers, smelters, chemical plants, etc. How does it work? The core concept of every sushi belt is the rotating set of goods needed to fulfill a machine. The way you go about doing this can differ, but for a robust system, you need three components: the loop itself, a system that recycles excess goods, and a system that imports goods into the loop. Additionally, for more advanced systems, an unloading mechanism for output goods. In the example here, we are doing that on a separate loop, but you could put the goods back on here and take it off at some point. Generally, most recipes require 2 or more inputs and provide 1 or more outputs, all of which in a standard build require dedicated belts to deliver and collect. With a sushi belt, you can achieve the same throughput as multiple belts without needing additional sorters to input into each building and the space required by said belts. This in turn can save you space, materials, and time building more compact systems than if you were using many belts. This of course also translates to performance improvement. You might be thinking, that all sounds great. Why would anyone want to use standard multi-belt setups? Well, the main drawback to sushi belts is their relative complexity. There's a much larger upfront cost of time to figure out a system that works for you before you can go about implementing it and pasting blueprints. But once you have mastered it, it will be almost as simple as setting up a multi-belt system. The most common type of sushi I found online used splitters to control the input ratio of items entering the loop. However, this system is not without its flaws. As you can see here, if a good does not get used up, it continues to circulate around the belt. This can become a problem. I am currently removing the excess items so that fresh items can enter the loop here. However, once I remove this traffic monitor and increase the speed at which items enter this loop, what you will notice is a buildup of Dyson sphere components and quantum chips, and a lack of fuel rods. The reason this is happening is because the factory consumes twice as many fuel rods as the other 2 components. And eventually, what will happen is this loop will get blocked up. This is an issue. We can resolve this issue by recycling an item once it has made its way around the loop. In this example, I am using splitters with filters to filter off excess goods onto their own dedicated belt. That then prioritizes input over existing goods using this simple T-junction here. A simple swap then becomes power sorters to replace the bulky splitter, allowing verticality as well. To take this one step further, we can make use of different belt speeds to change the ratio of goods entering the loop. Here you can see a 2:1:1 ratio, which is the correct ratio for this factory, of fuel rods to quantum chips to Dyson sphere components entering this loop using this MK3 belt. If I was to pause this, you can see 2 fuel rods and 1 of each other material, which then circulates and then gets recycled. Taking these concepts and tidying it up a little bit by trimming the dedicated recycling belts, you end up with this. An item enters a loop here, goes around, gets consumed. If it doesn't get consumed, comes back around, the power sorter picks it up, and with priority, it re-enters the loop. So we know that on this loop, there can be no more than 6 per second items because of this conveyor belt here. And because there's a double T-junction, we know that these items will not take priority, and these items will not take priority over the ones on the belt, so it cannot clog. Finally, I wanted to demonstrate a lack of one of the input goods to show a shortage, and to show that the sushi belt will not clog. This can be a common scenario, and as opposed to the splitter designs, this is capable of maintaining correct item count on the belt to allow for the missing item to input when it arrives, which I can demonstrate now. As you can see, the item inserts itself and starts the factory back up. And the excess goods just continue to recycle. You should now be able to deduce exactly what's going on this factory with the quadruple parallel sushi belts. Although it might still seem a little bit confusing, what you actually have is a distribution system on top that splits the incoming belt of 3 different items into the 4 sushi belts, and then distributes it down the line into the 8 factory line, which then loops back on itself, and upon doing so, the items are extracted. So in this example here, they get pulled off, go through this perforator and into the ILS, and anything that's left over goes back up into the distribution system. I hope this gives you some ideas, and if you have any more questions, please let me know down in the comment section. I'll try and answer as best I can. Thank you for watching, and stay safe.